Hello guys, welcome. Today we are going to do revision under probability. Without wasting time, let us begin with this question. So let's first of all read the question. A number is selected at random from 2, 3, 5, 7, 9, 11 and paired with another number selected at random from 4, 6, 8, 10, 12, 14. Determine all possible outcomes, that is Roman 1. Roman 2. Determine the probability that the sum of the selected numbers is even. Roman 3. Determine the probability that the sum is greater than the greatest number that can be selected. And Roman number 4, determine the probability that the sum is odd and prime. Part B of the question is totally different from the first question, so we'll check it later after doing the first question. It's always advisable for a student to understand the question before attempting it. So this type of a question, with for a student who does revision a lot, he or she will realize that there are two groups of numbers here. This part, the first part, is the first group of the number, and this one is another group of the numbers. So this one alone gives a student an idea that the kind of diagram I'll have won't be a tree diagram. Rather, it will be a table diagram. It is only revision, and revision will enlighten you to other various types of questions that you might come across, and you will be in a position to know how to tackle these type of questions. So let the first group be given an unknown letter, and in my case I'll use Y, and the second I'll give it another unknown letter which will be Y. So because I have a smaller space here, allow me to do the question in another page. So we have X. So I'll have to construct a table diagram. A table diagram. So let me have something straight. So I will have X all over Y. Yx all over Y. So X will be written in the horizontal column and Y will be written in the vertical column. The horizontal is this column. I'll have to write my numbers there, and the Y group will occupy the vertical column or the vertical columns. So under X we have 2, 3, 5, 7. 2, 3, 5, 7. 2, 2, 3, 5, 7. 2, 3, 5, 7, 9, 11. 9, 11. Then I'll have them in a group column like this. Then for Y, we have 4, 6, 8, 10. 4, 6, 8, 10. We have 4, 6, 8, 10, 12, 14. 12, 14. Then they are also given in group or column in rows this way. So let's read the question one more time. A number is selected at random from 2, 3, 5, 7, 9, 11 and paired with another number selected at random from 4, 6, 8, 10, 12, 14. The keyword there for this question is paired. The numbers have been paired. So, okay, so we have 2, 4. This is how the numbers have been paired. So we have 2, 4. 3, 4, 5, 4, 7, 4, 9, 4. Allow me to write the pairs in another ink. So let us have that one. So let me do that, then we continue. So here we have the numbers paired. So remember the question asks, determine all possible outcomes. And this is what should be your answer. Your answer should not be the numbers at 2, 4, 3, 4, 5. No, your answer should be in a table form like this. And these are the possible outcomes. This is the first answer, and you will get your 2 marks. I don't know if it is 2. Yeah, you will have your 2 marks. So always learn to squeeze your work, but in a way that it can be read very clearly, so that you arrange your work neatly. And this space, I know for someone writing, I know that space is enough. Roman number 2 reads, the probability that the sum of the selected numbers is even. So these are the numbers that are selected, guys. These are the numbers that are selected. So Roman number 2 wants us to get the probability that the sum of the selected numbers is even. So that means what? We shall add the paired numbers. That is 4 plus 2, 3 plus 4, 5 plus 4, 7 plus 4, up to the last part of it. Then we shall look for an even number. We all know that an even number is a number that is divisible by 2. So that is what we are looking for. But before doing that, let us first of all add the paired numbers. After getting the sum, we have this. So I've written them in this color. Is it blue or I don't know, but that color, that different color from red. So that is the sum. 6, 7, 9, 11, 13, 15. So the total outcome we have is a 36. How do I get that? How do I get that 36? You can count it manually. 1, 2, 3 up to the from this point to this end. You can count it manually. You'll get 36. Or you can count the horizontal column, the vertical, and you multiply by the vertical column. That is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 times 6, 36. That is the total outcome in the table. So let us answer the Roman 2 question. The probability that the sum of the selected numbers is even. And an even number is a number that is divisible by 2. So we have 6. 1. So count with me, guys. Count with me. So count with me. We have a 1, 2, 3, 4, 5, 6. We only have those 6 even numbers. 6 even numbers. There are no other ones. There are no other ones. It is only those. So our answer to this Roman 2 will be 6 out of 36. That will be the answer there. Roman number 3. The probability that the sum is greater than the greatest number that can be selected. This question can be tricky if English is not your favorite subject. This question can be tricky. You can struggle to understand this part of question, and that is why I told you that it is good, first of all, to understand the question. If you understand the question, then English will not be a problem to you. The probability that the sum, determine the probability that the sum is greater than the greatest number that can be selected. Greatest number that can be selected. Remember, we had 2 groups of numbers. The first group was X and the second group was Y. So in those 2 groups of numbers, which is the greatest number in those groups that can be selected? The number is in group 2, that is group Y, and that greatest number is 14. 14 is the greatest number that can be selected. So they want the probability that the sum is greater. The sum is greater than the greatest number that can be selected. And the greatest number that can be selected in those 2 groups of numbers is 14. So in other terms, already we have the sum. So just check or just count where the sum is greater than 14. So let's go back. Where the sum is greater than 14. The sum is greater than 14. Let me use another color. Let us have this one. So the sum is greater than 14. That is only what we are looking for. So we have 1. That sum is greater than 14. So we have 1, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we have 21. We have 21 all over the total 36. Remember, you must be in a position to understand the symbols. Greater than is not the same. Greater than is not the same or not equal to greater than or equal to. If this symbol was used, or if an examiner could have said the probability that the sum is greater than or equal to, this is the symbol, then 14 could have been included. But being that the proportion, the sign used there is greater than, so that automatically exclude 14. So 14 is not included among the numbers that is greater than 14 in the group of numbers. So we are having our answer 21 all over 36. Roman number 4. The probability that the sum is odd and prime. The probability So the probability that the sum is odd and prime. Remember, at the first or at the beginning of the lesson, there's something we discussed. There are two terms an examiner uses, and or. When and is used in a question, that is a multiplication, or that is an addition. So don't, this and is not here by mistake, or it is not here as a connecting word, that is odd prime. No, it is there for a reason. It is there for a purpose. So let's go back. We all know that an odd number is a number that is not divisible by 2. A prime number is a number that has only two divisors, that is 1 and the number itself. So let's come back to our sample space. This diagram is really helpful when it comes to answering those other questions down there. So allow me to remove these yellow and the green colors first, then we continue. So we have this. So together, first of all, let us get the odd numbers. How many are they? Let us get the number or the probability of the odd numbers that are here together. So let us count together. Let us count together. So odd number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or by the way, the simplest way we can get the odd numbers. Remember, first or initially, we got the probability of the even numbers. And the probability of the even numbers, they were 6. So you take 36, that is the total outcome, 36 minus 6. So we get 30. So the odd number, we have 30 all over 36. But again, you can just count manually. You can count manually. You can continue counting this way. But that is a wastage of time. So the odd number, we have 30 over 36. So let's check the prime number. Remember, a prime number is a number with only two divisors. What do I mean by two divisors? Only two numbers can go into that particular number. That is 1 and the number itself. No 2, no 3, no any other number. The number itself and 1 only. So let us get the prime numbers. So let's get the prime numbers. So the prime numbers, so we have 7. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 21 is not, is 21? 21 is not a prime number, sorry guys. So we have 11, 12, 13, 14, 15, 16, 17. So we have those ones, 17. So there are 17 in total. So prime number, we have 17 out of 36. So back to the question now. So remember, the probability of odd and prime is the same as taking the probability of an odd number, you multiply by the probability of prime numbers, and already we've obtained the particular numbers. So let me delete these ones then so that we have space. So we have the probability of odd, which was 30 all over 36. We multiply by the probability of prime number, which was 17 all over 36. Have this one in your calculator. Have this one in your calculator. We shall get our answer as 85 all over 216. There is no single day that you will get a probability that is greater than 1. If that is the case, then know you are doing your own things. No, you are doing your own things. So let's come to the last part of the question. So that was that. So part B. A bag contains 10 red balls and 6 yellow balls. If the balls are drawn out of the bag at random, one at a time without replacement, what is the probability that the two balls are of different colors? So this is the only part of probability that seems to be unreality, but we shall discuss that one later. So first of all, let us have the sample space, and obviously this one will be a tree diagram. So we have the ball. So the ball contain red balls and yellow balls. So we have 10 red balls and 6 yellow balls. The total is 16. So out of 16, if the balls are drawn out of the bag at random, one at a time, without replacement, what is the probability that the two balls are of different colors? So this is the first pick. Whatever we've drawn here is the first pick. Now the second pick, okay, sorry. I know, and that is why I told you this is the part of probability that always seems to be unreality. Because we are being told what is the probability that the two balls are of different colors. So you will have to reason how many picks have this person made. Is it one pick or two picks? If it is two balls, then the number of picks is always less than the number of balls given. It is always one less with the number of balls given, the number of picks. The number of picks is always one less with the number of balls. So here we have two balls. That means we have one pick. So we shall have here the first pick. So we have red, yellow, red, yellow. So this is what will give you the sample space or the outcome. Remember, the balls are being drawn out without replacement. There is no replacement being made. So if in red we had 10 balls, and one is already drawn out, how many balls are remaining? It is 9. 9 out of what? Now remember, the total reduces by 1. The total number of balls in that particular box or that particular bag was 16. So we shall have 9 out of what? 16. Remember, in the yellow column or in the yellow part, no ball has been picked yet. So we shall have the constant number of yellow balls because no yellow ball has been picked there. So yellow will remain just to be the 6 out of what, guys? Out of 15. I'm sorry for writing that part 16. It should be 15. Sorry for that. This part should be 15. Sorry. Come to the yellow. Now yellow bag has been drawn. What is the number of balls remaining? What is the number of yellow balls remaining if already one is drawn and there were 6 in total? So 5 is remaining out of what total? Now remember, the total number of bags were 16. So when one is drawn, they are reducing by 1, where we have 15. Red is never picked in the yellow part or in the yellow column. So red will just remain to be the number of balls. The number of red balls will remain to be constant. So we shall have 10 all over the total 15. So our sample space, we have red, 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 yellow, yellow, red, and yellow, yellow. What is the question asking? What is the probability that the two balls are of different colors? Different colors. We have red, yellow, and yellow, red. Remember, back in the previous lesson we've done, I told you that red, yellow is not equal to yellow, red. Why? There is a way probability is being read. When it is red, yellow, that means that red was picked first. Red was picked first. When it is yellow, red, yellow was picked the first one. So that is why red, yellow is not equal to yellow, red. Yeah, that is it. If you are not understanding, just do a lot of revision. You will expose yourself to more different type of question and you will be able to understand better, or maybe get a friend whom can help you. But again, also I can always help you. So let us get the probability. So the probability, we have red, yellow, or probability yellow, red. Why should I use or? Because you can pick red, yellow, or maybe you can pick yellow, red. That's why I'm using or. And when I use red, yellow, there is and invisible in between those two red, yellow. So red, yellow, we have 10 over 16. 10 over 16. You multiply by yellow, 6 over 15. 6 over 15. And because or means addition, we are going to add yellow, red, yellow, red. So yellow, we have 6 out of 16. You multiply by red. That is 10 over 15. 10 over 15. So having this in your calculator will give us what? So we are going to have our answer as 1 all over 2. 1 all over 2. So let's check another question. Let's check another question if there is in this part. Number 10. Very nice and interesting question. You only have to reason. This is not probability like that probability that you are used to. You only have to reason. Now, there are 3 athletes, A, B, and C, in a 100-meter race. A is twice as likely to win as B, while B is twice as likely to win as C. Find the probability that A does not win the 100 meters race. A student will read the question, then just give up. Why? Because of the English used. And that is why I told you doing more revision will make you, you'll just see a question, then even without understanding the English in it, you can still be able to tackle the question. So we have the question here, guys. The question reads, there are 3 athletes, A, B, and C, in a 100 meters race. A is twice as likely to win as B, while B is twice as likely as C. Find the probability that A does not win the 100 meters race. Very nice question. Now, this type of a question is not that much the same as those other type of probability we've been dealing with. These are reasoning probability. You have to reason a little. It's more of algebra. Yeah, this type of probability is more of algebra. So you will have to reason at the same time. You'll have to reason at the same time. Okay. I'm working on a word page. So let me look for a page. Now I have this. So we have A, we have B, and we have C. Very nice question. Let's read it again. There are 3 athletes, A, B, and C, in 100 meters race. That is just a sentence, just a clue to let you know whatever is happening. So the headache comes after that full stop. A is twice as likely to win as B. A is twice as likely to win as B. Whatever comes the second, let it be unknown. Whatever object that comes the second, let it be unknown. So what is coming the second here? B. So let B be X. Let B be X. Come back. A is twice as likely to win as B. That means we shall take A, the value of A, we multiply by the value of B. The value of A is 2. Multiplied by the value of B, which is X, what are we having? 2X. 2X. So the question is right. A is twice as likely to win as B. That means what? A has higher chances of winning than B. That is algebra. Let's continue. And that is why you don't have to love another topic, hate another topic. These things, they are related. So if algebra was never your favorite topic, then you are out. The marks here, you are out. But let's continue. While B is twice as likely, I think that there was something wrong with that part. The question should have read, while B is twice as likely to win as C. So that is what should read there. While B is twice to win as likely as C. That means what? B is greater than C. B has higher chances of winning than C. So how is that algebra represented? While B is twice as likely to win as C. So 1 all over 2x. That is what should be represented in algebraic way. B is twice to win as likely as C. C has lower chances of winning compared to B. Having that, let's continue. So let's get the total sample space. The total, so that is 2x plus x plus a half x. Adding that, we are having 3.5x. So that means the probability of athletes winning, the probability of athletes winning will be what? Now A will be 2x all over the total, which is 3.5x. B is x all over 3.5x. And C, it is a half x all over 3.5x. Having that, then use a calculator to simplify them. So take 2 divide by 3.5. What are we having there? 4 over 7. Now remember, we don't have x because the x cancels one another out. So 1 divided by 3.5, this part, we are having 2 all over 7. And this part, we are having 1 all over 7. So that means probability of A winning will be 4 all over 7. The probability of B winning will be 2 all over 7. And the probability of C winning will be 1 all over 7. But is that what the question needs? The question wants, find the probability that A does not win. Read and understand the question. Find the probability that A does not win. Whatever we were given first was the probability of each team winning. But now whatever the question wants is the probability of a team, one team not winning. So the question is specific on A. Now, if the probability of A winning, if the probability of A winning is 4 all over 7, then what is the probability of A not winning? What is the probability of A not winning? Take 7 over 7 minus 4 over 7. Take the whole, okay, just take 1 minus 4 over 7, which is the same as 7 over 7 minus 4 over 7. So that means probability that A will not win is 3 over 7. And this should be your answer. If you have any question, you can put it there in the comment section. We shall discuss. But I have a question that I want to leave you with. The question is not difficult. And remember, there are some parts of the question that still we haven't tackled. We have conditional probability. We have not tackled those, or that type of question. We haven't looked at it. But I don't know if still we have time. We can check it. Let me look for one if I'll get. So here, guys, I have a question under conditional probability, which I want us to look at first. Now, I remember telling you something about conditional probability. That, okay, probability has 4 areas. That is experimental probability, theoretical probability, combined, and the conditional probability. And the most probability you'll always come across with when it comes to 10 marks problem is either conditional probability or the combined probability. And combined probability is a combination of theoretical and experimental probability. So, before doing any question under probability, when it is 10 marks, if it is 10 marks, ask yourself, which type of probability am I dealing with? Is it conditional probability? Is it combined probability? And if it is combined probability, in which category is it at? Is it under independent probability or mutually exclusive probability? If you can be able to answer those questions, then getting the 10 marks in that particular problem will not be difficult. Remember once again, the kind of tree diagram that we uses in independent probability is different from that type of tree diagram that we shall draw when it comes to a mutually exclusive probability. I remember telling you that independent event or independent probability is the occurrence of one event that does not affect the occurrence of one event. If one event occurs, it does not affect the other one. That is independent. For mutually exclusive event, the probability where event A will occur, and if it has occurred, then the other event will not occur. What do I mean? For example, if I have a coin, if I flip the coin, if I get the tail, that means I don't get what? I don't get the head. So that is it. So make sure you are in a position to answer those. You are in a position to understand, is this one independent probability? Is this one mutually exclusive probability? And remember, mutually exclusive probability almost they have the same tree diagram as conditional probability. So we still have one more question to do, that is combined probability. So this one is conditional, I'll do combined, then we close our chapter, do the next topic, which is calculus. But for you, you can still do more revision. So let's begin. The probability that John visit Masai Mara is 3 all over 5. So let us have our working there. So we have John. So the question reads, the probability that John visit Masai Mara is 3 all over 5. So we have the probability of visiting. He can visit or fail to visit. So fail to visit, we always write the prime. That is V and prime. This is what we always call prime. That small notation there that looks like a power something. That is the prime. So V, visit. V prime, not visiting. So we can have it that way. The probability that John visit Masai Mara is 3 all over 5. So if we visit, we have 3 all over 5. The probability of not visiting will be what? 2 all over 5. 2 all over 5. All over 5. If he visit Masai Mara, the probability that he sees a lion. So if he visit, so the probability of him seeing a lion, and there's a probability of him not seeing a lion. So the probability of him seeing a lion, if he visit Masai Mara, the probability that he sees a lion is 7 over 8. The probability that he will not see a lion is what? 1 all over 8. 1 all over 8. So let's continue. If he does not visit Masai Mara, that is the V prime. If he does not visit Masai Mara, the probability that he sees a lion is 1 over 10. The probability that he will see a lion is 1 over 10. That means the probability that he will not see a lion is what? 9 over 10. 9 over 10. So we have our outcome. The outcome, you will visit and see a lion. You will visit and fail to see a lion. You will not visit, but you will see a lion. You will not visit and you will not see a lion. So we have the tree diagram here that will help us to solve the question. Remember, when your tree diagram is wrong, then an examiner will not bother to check whatever you are working is, because automatically those will be errors. So always make sure in probability your tree diagram is right. So let's check the first pattern, the first part, that is question A. Find the probability that he will visit and see a lion. He will visit and see a lion. So it is only one. Visit and see a lion. He will visit and not see a lion. He will not visit, yet he will see a lion. He will not visit, he will not see a lion. So whatever we are being required to get in the first part is visit and see a lion. So we have that part A. Part A, we have 3 over 5 multiplied by 7 over 8 multiplied by 7 over 8 multiplied by 7 over 8. Having your calculator, what is that? 3 over 7, sorry, 3 over 5 multiplied by 7 over 8. We are having 21 all over 40. So that's the probability. So part B, he will not visit, yet he will see a lion. He will not visit, yet he will see a lion. Remember this one, he will visit and see a lion. But we are being asked to that the probability that he will not visit, yet he will see a lion. So that is 2 over 5 multiplied by 1 over 10. 2 over 5 multiplied by 1 over 10. 2 over 5 multiplied by 1 over 10. That one is 2 all over what? 50. You can simplify further to get 1 all over 25. To get 1 all over 25. Then part C, he will see a lion. So here, he will see a lion. Remember here, he will visit, yet he will not see a lion. So this one is not considered. In this other part, he will not visit, yet he will see a lion. So there is only 2 chances. Visit and seeing a lion, not visiting and seeing a lion. So we have those. So we have part C, we have probability of visiting and seeing a lion, or we have the probability of not visiting and yet you will see a lion. So we just have visiting and seeing a lion already, we've already gotten there, that is 21 over 40. You add to probability of not visiting and yet you will see a lion, that is 1 all over 25. Very much connecting, that part is very much open. So adding that, we are having 21 over 40 plus 1 over 25, we are getting 113 all over 200. 113 all over 200. So let's check the last revision, that is a combined probability, and we shall say something in that part. So here we have the combined probability. I myself have I've checked for one, I've looked for one. In an exam, no one will tell you that this one is a combined probability. This one is a conditional probability. It is you yourself to identify, oh, that this one is a type of this type of probability. Now, how will you be able to know that? You first of all read the question. After reading the question, read it one more time and another one more time. That is 3 times when it comes to probability. Because remember in that section B, there are, I don't know, there are 7 questions. And if you choose on probability, make sure you are understanding that type of probability. Read, and understand before attempting the particular question. So let's have this. Let's read this. Kamau, Njoroge, and Kariuki are practicing archery. The probability of Kamau hitting the target is 2 all over 5. That of Njoroge hitting the target is 1 all over 4. And that of Kariuki hitting the target is 3 all over 7. Find the probability that in one attempt, part A, only one hits the target. Part B, all three hits the target. Part C, none of them hits the target. Part D, 2 hits the target. And part E, at least 1 hits the target. If you read the question, you will realize that there is nowhere you are being asked to draw a tree diagram or to present a diagram, be it a table or a tree. You've not been asked that. But this type of question, the only way you can escape getting 0 in this type of question, you must come up with a good sample space. You must come up with a good sample space. So, read the question once again, then ask yourself, okay, before asking yourself, in the process of asking yourself, we have how many types of probability? There are 4 categories of probability: experimental, theoretical, combined, and conditional probability. Now, in the process of asking yourself, try to recall that I once watched somewhere, or maybe a teacher taught me somewhere, that there are only 2 probabilities that will always be examined by the examiner. And which probability is that? Combined probability and conditional probability. If we're in a position to understand the conditional probability, then we will only have one option, that is combined probability. Now, if conditional probability is not within your jurisdiction, then consider this type of question being what? Combined probability. Now again, ask yourself, if it is combined probability, it is in which category? Is it independent probability? Or is it mutually exclusive probability? While asking yourself those questions, you must be in a position to understand that, to know independent probability and mutually exclusive probability. Independent probability is where the occurrence of one event does not affect the occurrence of the other event. With the mutually exclusive event or probability is where this is the probability that either event A can occur or event B can occur. And if event A occurs, that means that event B will not occur. Are we understanding one another? Now, if that is that, this type of question, it is an independent event. Why? Because if Kamau hits the target, it will not affect Njoroge. Njoroge can hit the same target or fail to hit the same target. If Njoroge fails to hit the target, it will not affect Kariuki. Kariuki will also come and try his part if he hits or fails to hit. So that event is not affecting these people. The event of practicing archery is not affecting one another. If I hit, how will it affect you? No way. Now, if you can understand that one, then again, there are two options. The kind of sample space under tree diagram for independent event is totally different from the kind of sample space for mutually exclusive event. Now, if you can understand that this type of question is an independent event, then how is the diagram being drawn? How is the tree diagram being drawn? Very much easy. We have three people. Again, be very careful not to draw big diagram because it will not be that much easier. It's always something complicated, but way more easier. So let me start from almost this part. So we have three people. We have a Kamau, Njoroge, and Kariuki. So we have Kamau, Njoroge, and Kariuki. Kariuki. Let us have Karen. So let's read the question. And I've done one very big mistake. Why? This is not the right tree diagram. When examiner will just see Kariuki, Njoroge, and Kamau written at the very far end of those arrows or of those lines, consider yourself 0. How then should it look like? So Njoroge and Kariuki, whatever, they should not be there. So a dotted line should be drawn separating those people this way. So the first column is for Kamau. Then we have this. And that is why I told you that it is always more complicated when it comes to the independent event. So this other part, we have Njoroge. Then again, they are being separated that way. So at the very far end, this other part, we have who? Is it Kariuki? Yeah, Kariuki. So the arrow, this first arrow is for this guy. Then this one is again for this. Then we have this other part. So this one is for this guy. Kindly don't be mistaken. Then this one is for this guy. This one will be for the other person. Then this one will be for the other person. It is always complicated. That is the truth. But it is the only way which you can use to get the accurate answer you are looking for. But once you've understood, nothing will be difficult. So we have that. Now, Kamau, Njoroge, and Kariuki are practicing archery. The probability of Kamau hitting the target is 2 all over 5. The probability of Kamau hitting the target is 2 all over 5. Oh, I am sorry, guys. I've made a mistake here. Let me correct it. Sorry for the 3-tree diagram. There are only 2 chances here. These guys can either hit or fail to hit. So sorry for the 3 arrows that I had initially drawn. So it can be hit or fail to hit. So the same applies. The same applies to the Njoroge, then being separated by a line there. And this one we have, so sorry guys, I'm honestly sorry. Then we have this. So we have Njoroge. Njoroge can hit or fail to hit. The same to Kamau, Njoroge, and Kariuki. So can hit or fail to hit. Can hit or fail to hit. Can hit or fail to hit. Can. But also an examiner will set something reasonable with the capacity of students. An examiner will not just set something complicated. So let's do the question very fast. Let's do the question. The probability of Kamau hitting the target is 2 all over 5. Probability of Kamau hitting the target is 2 all over 5. Not hitting the target is 1 all over 5. 1 all over 5. Let's take the side of Njoroge. That of Njoroge hitting the target is a quarter, 1 over 4. Njoroge hitting the target is 1 all over 4. Not hitting the target is 3 all over 4. 1 all over 4. 3 all over 4. Great. How about Kariuki? And that of Kariuki hitting the target is 3 all over 7. 3 all over 7. So Kariuki hitting the target is 3 all over 7. Not hitting the target is what, guys? 7 minus 3, that one is 4 all over 7. 3 all over 7. 4 all over 7. 3 all over 7. 4 all over 7. 3 all over 7. 4 all over 7. This is the most easiest way you can tackle probability. This is the most easiest way, by having the right tree diagram. There are some students that can do the question minus having the diagram, but it is risky because an examiner will want to know where have you gotten your values from. An examiner might even think you are cheating. So it is advisable to have the tree diagram. So the outcome, we have hit. Hit, and fail to hit. So that one, this. And again, also be very careful when you are mentioning your sample space, your outcomes. It is very challenging, very confusing. So hit, not hit. Then we have hit, not hit, hit. So we have hit, not hit, hit. Then this column we have hit, not hit, not hit. Then the other part we have fail to hit, hit. Then we have not hit, and fail to hit. Then again hit. And then this other part we have fail to hit, and we have the very last part, not hit, fail to hit, fail to hit. You also must be doing your rough work somewhere so that if I mess, you can do the correction, but you must understand. So having this is way more easier, because if you have the right tree diagram, then consider the 10 marks being yours. Consider the 10 marks being yours. If you have the right tree diagram, so let me separate the tree diagram from our sample space so that don't forget. Okay, now we have this very much now, right? So now let's do the first question. Let's answer the first question. Find the probability that in one attempt only one hits the target. Only one person will hit the target. Only one person will hit the target. Now this sample space is giving us all the details we require. This one is X. Why? Because this first, they all hit. They've all hit. Coming to this, only two have gotten, have hit. Here also two. Here one. So we shall consider this, the very first one. How about this other one? It was, this one was hit. Yeah, this one no. This one no. We have this one, yeah. This one no. This one no. So the probability that only one person will hit. So the probability that only one person will hit is the probability of hit, not hit, not hit. So hit, not hit, not hit, or the probability of not hit, hit, not hit. I'm using a red color so that you can understand. So now let's have this in numbers. So this other part, so make sure you are getting the values you will be getting are from that column you've taken your values from. So we have hit, not hit, not hit. So hit, we have 2 all over 5. 2 all over 5. Let us so hit, we have 2. So we have 2 all over 5 multiplied by not hit. Not hit, 3 all over 4, 4 all over 7. 3 all over 4 times 4 all over 7 plus not hit, not hit. So again, the other part, this one, its value will be from this. They will be generated from this. So that is not hit, hit, not hit. Yeah, very much correct. So we shall have 1 over 5 times a quarter. 1 over 5 times a quarter times what, guys? Times 4 over 7. Times 4 over 7. So just punch this in your calculator. So having this in your calculator, we shall get our answer as 1 all over 5. 1 all over 5. So that is the answer to that question, part A. To that question A. Part B, all 3 hits the target. All of them hits the target. So come back to the sample space. So come back to the sample space. So the sample space, checking at the sample space, we have the first, all of them hits the target. 2 hit, 2, 2, 1, 2, 1, and none of them hits the target. So that means it is only one in one attempt that all of them will hit the target. So that is the probability of them hitting, the probability of H. The probability of them hitting, which will be what? So that one will be 2 over 5 a quarter, 3 over 7. 2 over 5 a quarter, 2 over 5 times a quarter times 3 all over 7 times 3 all over 7. Have this in a calculator. So we shall have 3 all over 70. 3 all over 70. 3 all over 70. Now, part C, or the next, none of them hits the target. None of them hits the target. So this first, only 3 of them hits. Here 2, here 2, here 1 hits the target, here 2 hits the target, 1 hit the target, 2 hits the target, none of them hits the target. So this is what we are looking for. None of them hits the target. So that one is probability of not hitting, not hitting, not hitting. So that is what? 1 over 5 times 3/4 times 4 over 7. So that is 1 over 5. Is it 1 really? It should be 3. Oh, sorry, 1 over 5. Yeah. 1 over 5 times 3 over 4. 1 over 5 times 3 over 4 times 4 over 7 times 4 over 7 times 4 over 7. There is something that does not add up to me here. We've made a mistake. And that is why I told you, you must also have your rough work somewhere. So if you look at the part of Kariuki, the probability that Kariuki will hit is 2 all over 5. That means that the probability that Kamau will not hit is, this one is Kamau, sorry, not Kariuki, sorry. The probability that Kamau will hit is 2 all over 5. The probability that he will not hit should be, oh guys, I'm sorry. I'm really, really sorry. So the probability there should be 3. Should be 3, not 1. I'm honestly sorry for that. I don't know if there are other corrections this other part. So sorry. So let's check the part where we had 1 over 5. So it should be 3. So this part should be 3. So here should be 3. I'm really sorry for that. So that means this probability should be something. So probability in this part should be 9 all over 35. 9 all over 35, I'm sorry. And this other part I think is just right. We never tackled 1 over 5 somewhere. Here should be now 3 instead of 1. I'm sorry for that. So 3 over 5 times 3 over 4 times 4 over 7. We should be having 9 all over 35. 9 all over 35. Sorry for that, please. The next question, the next part, that is part C. We've checked at part C. Part D, only 2 hits the target. The probability that only 2 will hit the target, only 2 people will hit the target. So let me erase this first. Now they provide that only 2 people will hit the target. So we shall consider this one, only 2 people hitting the target. This one, this one, this one. There are 4. So we have probability of hit, not hit. So we have the probability of hit, not hit, or probability of what? Probability of hit, not hit, probability of hit, not hit, or probability of so let me write them. So we have this probability: hit, not hit, not hit, not hit, hit, and not hit. So getting these values from the tree diagram, that one should not be a problem to you. So I'll have to pause, then check for the videos. So under the first part, we have hit, not hit. So what do we have there? Hit, not hit. So we have 2 over 5 times a quarter times 4 over 7. So we have 2 over 5 times a quarter times 4 over 7. Plus, remember the or, what it means? The probability of hit, not hit. So probability of hit, not hit. So hit, not hit. So there we have 2 over 5 times 3 quarter times 3 over 7. 2 over 5 times 3 quarter times 3 over 7. So we have 2 over 5 times 3 quarter times 3 over 7. So the same applies to all of them. These are the probability, guys. I've really done quite a number of mistakes here. When it comes to this other part, the part here, this one that I've circled, this one, it should be hit, not hit. It should be not hit. But me, I wrote hit, not hit. That one should be wrong, guys. I've made quite a number of mistakes there. So that means after correcting this part, Then let's go back to was it the first question? Yeah. The probability that only one hits the target. The probability that only one person hits the target. So that means we must include this in our part A. This one was our A. So we must include, we must add. So remember, we've already gotten the 2. So it should be or probability of this one of not hit, and hit. So that one should be the probability of not hit. 3/5 times again not hit. That is 3/4 times the probability of hit. That is 3/7. 3/7. So when you take on that one, 3/5 times 3/4 times 3/7 is 27/140. So that 27/140, add it to 9/35. Add it to 9/35. So our answer here should be 9/20, not 9/35, but rather 9/20. Sorry for that. Yeah, we should be having 9/20. 9/20. These other parts are just right. These other parts are just right. So that means considering the probability, the part what? Considering the part, sorry, we've not that one. Considering part D, that 2 hits the target, only 2 people hits the target, we will only have 3 outcomes here. We will only have 3 outcomes. That is probability of hit, probability of hit, or hit not hit, not hit. We shall remove this one. We shall remove this one out. So we only have this. So let's have this in your calculator along the way it is. So having this in our calculator, we shall have our answer as 1/4. And that one should be the answer for that part D. Let's check the last part, which is part E. At least one hits the target. By the way, there are 2 terms here. We have at least and at most. It's only a matter of English. If you can understand English very well, then you are good to go with this type of question. So we have at most. Okay, if someone should tell you that I want at most 3 students, if a teacher should call you and tell you that call me at most 3 students, then you should go and either call 1 student or 2 or maybe the 3, but not 4. Or maybe you can fail to call any student, because at most means 0, from 0 to 3. The numbers have been included. And when the teacher talks of at least 1, or sorry, at least 3, that means that a teacher will want 3 students and above. You can even call the whole school to him, or maybe her. It will be okay because of the word at least. So at least 3 means from 3 up to the maximum number that you can get. But at most, it is from 0 to that very number that you've been told. Maybe if it was 5, at most 5, then it is from 0 up to 5. It should not exceed 5. When it is at least 5, it should be 5 and above. From 5 is included. So it should be from 5 to the maximum number of students you can get. So make sure you know those terms at least. So at least one hits the target. So what are the question is either one hit or all of them hits. Either one or all of them. Okay, when you come here, this means that this one is included, 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 not included. Why is it not included? Because all of them have failed to hit. Oh, I'm sorry. This one is included. This one is the one not included. Why? Because all of them have failed to hit the target. They failed. So this question is very easier. We should not waste a lot of time. So being that at least one hits, just take one minus all of them missing the target. And all of them missing the target, we've already gotten the answer somewhere. But so all of them missing the target, that one was question under part C. None of them hitting the target. So you can take one minus none of them hitting the target. So this one was our part A. This one became our part B. And this one became our part C. So part C. Yeah. Then this one became our part D. Then the very last question we are doing is our part E. So it is 1 minus none of them hitting the target, which is part C, 9 all over 35. So you subtract 9 all over 35. Or you can go step by step. You take 1 minus 3 into bracket 3 over 5 times 3 over 4 times 4 over 7, which you will still end up with 9 all over 35. Or if you want to waste time in an exam room, you can go per group. You calculate this group, put aside. Calculate this group, put aside. Calculate this group, put aside. By the time you realize that, by the time you finish, you will realize that you have only done one question in the entire session with 2 hours given. So you better do more revision to know how these questions are done. So 1 minus 9 all over 35 is what? 1 minus 9 all over 35. So that one is giving us 26 all over 35. So again, make sure whenever you've chosen to do any type of question, be it probability, be it any question at 10 marks problem, make sure you are very keen. This 10 marks problem can sometimes mislead you, and that is why it is advisable to do fast and finish before the 2 hours 30 minutes end. Then come back, check your workings. By that, you'll be able to save a lot. I thank you for watching. Follow more on the next topic, calculus. Very much interesting. But thank you for watching. Thank you.